This is our official start of our back to big data after our short break here. Last time we were in the week 6 folder, and we were working on this this Twitter Postgres assignment. So up to everything that we've done so far, working with Postgres just on getting the SQL select queries working, and that's what your midterm is going to be about. We'll talk about that here in a little bit again, review what to expect for the midterm. And then this assignment here, this Twitter Postgres, is starting to get us into not just selecting from the database, but inserting into the database and seeing different ways that we might format our database to be more or less efficient, various trade-offs. And we've actually covered everything in our last class that we need for this Twitter Postgres assignment. But today, the main portion of today is going to be to review some of the really tricky parts of this assignment, some of the gotchas, and then you'll be fully prepared for completing this assignment. The due date for this assignment is not this coming Sunday, but the Sunday afterwards, so the end of spring break. And this assignment here is not going to be on the midterm at all. So there's no time pressure at this point for this assignment. And again, I'm in the week 6 folder. Let's scroll down a little bit to have a few announcements for us. So again, it's good to see you all again. Probably a little bit sleep deprived at this point, so I might ramble or say something that's not totally clear. So feel free to interrupt me and ask questions like normal, but be extra good at asking questions today. Some administrative stuff. So all assignments at this point are graded in Sakai. You can go take a look at your current grades. With the Twitter MapReduce assignment, most people got full credit on that. 4 students missed some amount of points. And I have a short explanation for why you missed points if you did. But because it's a lot of stuff going on in the assignment, if you want to get a more detailed explanation about why you missed points, and maybe I might have misunderstood something and you want to explain it to me and try to get points back, that's totally okay too. Feel free to meet with me and we can talk about this. All of your Pagilla homeworks are also graded, and for the most part, everybody got full credit on that, or if you didn't, you already knew why you weren't getting full credit. But again, this is going to be the focus of the midterm, all of the SQL select statements from the Pagilla homeworks. At this point, lots of really great grades in the class. So the median grade is a 97%. And so I was talking to some of the other professors about this, mentioned that, and their immediate reaction was that, oh, you have to give a really, really hard midterm to bring down people's grades. And I don't believe in that. I think you all have earned your high grades at this point. And so I think the midterm will be a hard midterm, but it's not like an extra hard midterm because of this. It's just sort of the standard midterm. Any questions about any of that before we talk about the midterm a little bit?
Professor, can you share the screen?
Oh, thank you. Yes, if I'm not sharing the screen, I have atrophied my Zoom skills. There we go. Is that?
Yes, that's perfect.
Excellent. Yes, great question from Zoom about sharing the screen. Any other questions about administrative stuff before we go over what to expect from the midterm? Okay. So format, again, I mentioned this over the GitHub issues, but it's fully take home, OpenNode, Open Computer, any other resource you'd like except a fellow human. I will distribute it on Wednesday, sometime after class and after office hours, and then you'll have 2 days to complete it until Friday at midnight. Wednesday will be dedicated just to a review session for the midterm. I might have like 5 minutes of material at the beginning of the class, but otherwise it'll just be dedicated to whatever questions you all have. The class it'll be recorded, and so you're welcome to connect over Zoom or watch it later. But it'll be, if you do have questions, it's probably best to be here in person to ask those questions. And then, yeah, no class on Friday this week. If you'd like to see an example of a previous midterm, I have one posted right here. But the format's basically going to be very similar to the Pagilla homework assignments. The exact content of the midterm, there'll be 5 questions, each question worth 15 points, so 75 points total. So you have, depending on exactly which homeworks you've been required to complete so far, somewhere between 100 and 130 points outstanding. And so the midterm will be worth about 40-ish% of your grade so far. For the questions will be SQL problems based on the Pagilla assignments. And so in particular, coming from mostly from the homework 2 and homework 3 assignments, since those are the more harder ones. One of the differences between the homeworks and the way the midterm will be formatted is that you will not have access to the desired output on the midterm. So you did for the Pagilla homework so that the automatic grading system could work, but for this one, you will not have the desired output. And instead, the way the grading will work is that I will just manually read your SQL code, and if you have all of the main concepts, say joining whatever tables together, or the right roughly thing in the where clause, then you'll get full credit. If you're missing something, there will be no penalty for any sort of incorrect answer, so no way to get negative points, no penalties for guessing. There will be some opportunities for partial credit on the midterm, but I've been told at least that I'm less generous than other professors, and so the partial credit's relatively rare. Typically, the way the grade distributions work on this midterm is that there's maybe a third of the class gets really close to 75, like full credit, and then a large portion of the class misses 1 or 2 problems almost completely, maybe getting half credit on one of the problems. But the main way that people miss points on one of these problems is that if you misunderstand just like what the English of the problem is actually asking for. And if that's the case, then it'll be really hard for me to give you partial credit on the problem. So yeah, pay close attention to making sure that you're understanding like what the problem is actually asking for. Next class period, so in the review session, I'll go over exactly what I mean by this criteria right here. But just to ensure that I can actually read your SQL code and grade it effectively, 3 points out of the 15 for each problem will be that the SQL is formatted somewhat reasonably. And I'm pretty flexible about this, just has to be, so any of the things that I've typed up in class are examples of readable SQL code. And we'll go over, again, next class exactly what that means. This will just make it easier for me to grade. So those are the main parts of the midterm. Last question is on the column Tetris. And you'll need to be able to do both finding the number of bytes that a particular row is taking up. So being able to calculate that number based on the nulls and the actual types and the order that they're in. And then also rearranging the rows to get the optimal storage. Any questions at this point about the contents? Yes.
Will we have access to the schema of the database?
Yeah, so question, do you have access to the schema of the database? The answer is yes. You'll be using the same Pagilla schema, and you're allowed to not only have access to the database, you're allowed to open it up in Docker and Postgres and run your SQL commands, making sure that things seem reasonable to you. And then you'll, the only thing that's different is that you won't know like what the expected output is. You'll just have the English statement of it. That answer your question, Drew?
You might have mentioned this, but do you have office hours Monday, Wednesday?
Oh, good question. Yes, so I will have office hours Monday and Wednesday this week. So normally I would have a few other meetings scheduled too, but I only have one other meeting this week. So, and pretty much all of Monday and Wednesday I'll be in my office. Feel free to stop by and ask questions. Good questions so far. Any other questions? Yes.
You have an example of the structure of the output, like the column name or?
Yeah, good question. So you will not have an example output. So in the homework assignments, the homeworks were very picky about like the name of the column had to be exactly a certain thing, and not only did you have to have the ordering correct, like first name, last name, but sometimes it would matter if it's appended together or not. Those sorts of like very subtle things are not going to matter on the midterm. So you don't need to worry about that. It's just going to be like the main sort of structural things of, are you joining the right tables together? Do you have the right sort of subquery? Do you have the right things in your where clause? In certain situations, there could be like potentially multiple ways of interpreting something that I say, or interpreting the English, and in that case, any of the interpretations would be valid. Good question so far. Any other questions? Yes. Oh yeah. So if on the midterm itself you have questions, then so normally all other assignments collaboration is encouraged. Midterm collaboration not allowed. So you cannot post questions to GitHub for the midterm, but you can feel free to email me, and I may or may not be able to answer the question for email. But yes, you should certainly feel free to email about whatever's on the midterm. Good questions. Any other questions so far? Okay. Then again, I recommend for Wednesday's class to bring specific like content-based questions. How do you solve this particular problem? Why is this certain thing this certain way? And we can go over those on Wednesday. But today, the rest of today, we're going to be talking about this, this Twitter Postgres assignment, which again is not going to be tested on the midterm, but it is the next assignment that's due a week from Sunday at the end of spring break. But after today, we'll have covered everything that you need to complete the assignment. And so if it were me, I would not want to have it be doing it over spring break, and I would get it done pretty much right away. So we'll first review some of the things that we talked about last time, and then today we're going to be talking about the main gotchas with the assignment, things that might trip you up and how to avoid those pitfalls. So over here, I have my terminal screens opened, and I'm in my Twitter Postgres assignment right here. If I type ls, here's all the different files that we have. And the main difference about this assignment compared to the previous Pagilla assignments is we now have two databases that we're working with. So if I do ls services, there's these two databases right here, PG denormalized and PG normalized. And if we recall the denormalized version, so I'll do vim services / PG denormalized, and then we'll open it up, the schema.sql file. This contains all the database initialization code. In the denormalized version, everything is stored directly in these JSON-B types. The B stands for binary, so there's a binary representation of our JSON, just copied directly from those files that you were working with on Twitter. At this point, we're not working with the entire Twitter data set. We're just working with a small subset right here. It's got about 10,000 lines in it. You can do the unzip-p test data that outputs it all to the screen like this. So pipe wc-l, and there we go. We can see that there's 9,998 lines in this file that we'll be inserting right here. And in the denormalized, we're just storing it directly. And then we have a couple of views in here which give us the normalized sort of access into the into this information. In the normalized schema, there's no JSON stored. We're storing everything directly in SQL tables, and this information all somehow matches the things in the JSON blobs from the zip file. Coming back over to the web page for a second, and I'm going to click over here on the actual Twitter Postgres assignment right there. And scrolling down, we have this sort of overview of our schema of how all the different tables relate to each other. And last time we went over the main thing that we went over last time was focusing on the denormalized one. We started talking about the normalized one. The main part of this assignment is going to be getting the data into these two databases. We have inside of the SQL folder right here, there's a bunch of files that are already complete. I've already given them to you. So SQL *-p, the -p again opens up multiple files at once. And I've already given you the select queries for all of these statements here. They're sort of divided into two categories, these complex ones, which have actual interesting SQL queries, and these simple ones over here that are just counting how many things in each of the tables. In the test cases, so the test cases get run the same way as the test cases for the Pagilla assignments, just making sure that these SQL queries give us the correct output. But now we'll get the correct output only if we've inserted the correct data into the database. There's two scripts that you'll have to write, this loadtweets.py and this loadtweets.sh. Again, using the POSIX shell for this and Python for this. And the purpose of loadtweets.sh, let's start with that, loadtweets.sh. We have this testdata.zip file, and then two for loops looping over all the files. Here we have to load the normalized, and here we load the denormalized. The normalized is going to call the Python script for us, inserting it into the normalized database, and here inserting it into the denormalized database. And this is not going to use the Python files at all. I'm going to actually show us the solution for this test, the loadtweets.sh file here. In a second, let's do git checkout solution like this. And then up here, you can see in Vim, when I checked out the new file, nothing changed up here. In order to change this, I have to do :E, E standing for edit, to reload the file. And this is what the actual solution looks like for this file. And so you should feel free when you're working on this to check out the YouTube video and just copy and paste these lines exactly, or type them out exactly. Again, in the normalized loop up here, we're calling loadtweets.py. This URL right here corresponds to the way that we access the normalized database from outside of the database, so from the Lambda server. And then down here, we'll have a similar URL for accessing the denormalized database. One of the important things to notice is these port numbers over here. We have to pay particular attention to these port numbers. And let's see, let's do Docker compose down. And I'm going to check out my non-solution version for a second. So git checkout master. So this is what you're all provided with. And I'm going to do the Docker compose up-d, try to bring it up. And so this is the first sort of gotcha thing that's going to happen to you all, is that when you try to bring up Docker, it's not going to work. And the reason, if you may have seen messages similar to this in your past assignments, but anytime you see this cannot start service because the driver failed on the external connectivity on endpoint, this sort of error message It means for whatever reason, you are not allowed to start the database on the particular port that you're asking for. And up here, tab E to open a new file, docker compose.yaml. This is the file that we're reading to load things. And I want to look at the ports that we're currently using. So we have denormalized up at the top and then normalized down below. In the denormalized, I have port 1 mapped to 5432. The thing on the right, again, is the thing farthest away from you, so that's inside of the container. The thing to the left of the column is the thing that's closest to you, so that's on the Lambda server. So I'm trying to map port 1 on the Lambda server to port 5432 on the container. And then under the normalized, I have the 2 right here. And again, 2 on the Lambda server to 5432 on the container. You'll notice that the 5432 is the same for both the normalized and the denormalized one, because the Postgres port in the container is the same, but the thing to the left of the colon is different. And the reason we're getting these error messages is because in order to create a service listening at port 1 or at port 2, you must have root user permissions. You must be the admin of the system. And if we read this message in detail, here we go. That's what it says. It says you need to have root to do anything less than 1024. Since you're not root, you can't do that. And so the first thing that you'll have to do is you'll have to change these port numbers to something else that you do have permission for. Do a git checkout mask or git checkout solution, and we can see what I changed those port numbers to. And then up here, :E, like that, E to reload the file. And up here I use the denormalized is 25432, so I just put a 2 in front of the 5432, and then the normalized is 15432. In the past, you were able to use just your user IDs for the ports that you were trying to expose. In this case, since there's 2 ports you need to expose, you won't be able to use your user ID. You'll have to come up with some sort of formula that, that nobody else happens to be using. Once you have these 2 numbers right here for your port numbers, it's very important how they interact with the load_tweets.sh file. Because load_tweets.sh is being run from the Lambda server and not run from inside the container. It needs to know which one of these, it's going to access the servers using these ports right here. So if I want to access the denormalized, database, this is the port that I'll have to access it on. And so in the load_tweets.sh under load denormalized, I'll have to make sure that my URL down here has that same matching port number right here. Similarly, when I'm trying to access the normalized port, the normalized database using the Python script, I'll have to make sure that this port number right here matches what's in the Docker Compose file. That's the first gotcha for the assignment, and you won't really even be able to get started without getting this gotcha taken care of. And now down here, if I do the Docker Compose up-d, because the Docker Compose file, the ports are specified nicely, it's actually going to start. Any questions about that?
Why don't we have permission for certain ports?
Question is, why don't we have permission for certain ports? The answer is that ports less than 1024 are typically very special ports. So like port 23 is for SSHing into by default. Port 80 is for web pages. Port 443 is for secure web pages. And if a random user were to be able to create services on those ports, it's sort of like a, or if there is a service running on those ports, it's like a stamp of approval, like this is an official thing that is supported by the administration. And so by blocking off normal users from doing that, we prevent a random person from making it look like we're running a real web server.
Professor, I have a question.
Yes.
I was wondering, do we have to actually, after we change the port, do we have to like do the port redirection or not?
Question is, in the previous assignments with SSH, we had to do some port redirection issues. Does that play any effect here? And the answer is no. So you can use your normal SSH command without port forwarding. And the reason for that is because we're not trying to access any of these services from off the Lambda server. We're not trying to access them from your own physical laptop. All the access will happen on the Lambda server, and so we won't need to do port forwarding. You'll just have to secure that these two files match each other, loadtweets.sh and Docker Compose.
Yeah, and then I have this question. This is like, what did the time unzip actually do right here? Where you say for filing file do time, the time command before the unzip command in the
question is, what is this time command doing right here? And that segues us into the next thing that we're going to talk about in the next gotcha with this assignment. The literal answer to what this time is doing is that it's going to just measure the runtime of these two different commands. And so what I want to do next is run this loadtweets.sh from the solution and see whether it actually works or doesn't work. So sh loadtweets.sh, and we can see what's going to happen. There's, again, about 10,000 different tweets that are being loaded. So up here, it began with the normalized tweets at the top. It says load normalized right here. And then this is the output from the Python file. You can see that it takes about maybe half a second to a second for every 1,000 tweets that are being loaded. So this is, at this point, an incredibly slow procedure. Overall, it took 4 seconds to load 10,000 tweets. And then we also have, for the loading the denormalized down here, we can see the runtime. And for the denormalized, it only took 0.3 seconds. So the first advantage we see of the denormalized over the normalized is that, at least at this point, the denormalized is inserting much, much faster. The Python code that we're going to be taking a look at is sort of like worst case inefficient at this point. And one of the things that we'll be talking about over the next, I guess, right after spring break is why is that code inefficient and what are some ways of making it more efficient. The time command is what's giving us these outputs right here. What I want to do next, though, where I want to see what the next gotcha is let's go ahead and we'll do Docker Compose exec and PG. I want to run the test cases to see whether things worked or did not work. And I think last time I mentioned, or I've been using tab completion throughout this entire course with files mostly. And last time I mentioned that for some commands, you can use tab completion even with things that are not files. So here, Docker Compose in its third argument does not expect a file, it expects a container. And so I can use tab completion to get all of the different containers. I've just pressed tab twice and it shows me the list of the different containers that I can be using the Docker Compose exec command with. And I want to start with the normalized. So I'll just type in O and press tab, and then it gives me my normalized there. So tab completion, again, one of those things that super handy for avoiding typos and just making things generally faster. And then I want to run bash. So now I'm inside of the PG normalized container. And I can run the check answer script like this. And we can see that it happens really fast, checks that everything passes. So that's good. That's what we should expect to happen after we run the load data. Let's go ahead and type exit down here to leave out of that container, up arrow. And now back to so yeah, was normalized. We're going to go to the denormalized version now. I guess as an aside for me, I'm used to very long bash commands that spill over onto multiple lines. So this is perfectly natural for me to read. This normalized right here. See, I even double click in my terminal right here and it highlights things off to the next line because it comes down here. There's no new line involved. If I zoom out for a second, you can see that it's all on a single line like this. Zoom back in. But what I wanted to do, I want to now connect to the denormalized container, adding the DE right there. And so now I'm in the denormalized container, and let's see. You can see that I'm in a different container right now because down here in the prompt, so again, because we're logged in as root in the container, the final prompt symbol is a hashtag. Hashtag traditional for root, the $ traditional for any non-root user. But I know that I'm in a different container right now because this hash right here is the ID of the container, and this hash right here is different than this hash up here. So I know I'm in a different container now. And now I can run the check answer script like this, and you'll see that it's taking a lot longer to run this script. And you'll also notice that some of these are passing and some of these are failing. That's kind of super awkward. Why is that the case? And the answer is because of how the, see, I'm going to control, let's do exit here. The answer is how this, this loadtweets.sh script works. I'm going to open this. I guess we have it opened up already over here. When I run this loadtweets.py file up at the top, when I run loadtweets.py, the py is going into the normalized version of the database. Let's go ahead and take a look again at the normalized schema of the database. Up here, services / pg normalized / schema.sql. And one of the things that we have in this normalized database is a lot of primary keys. And again, a primary key is a shorthand for primary key equals not null and unique. There's no difference between saying primary key and saying not null and unique. And here, this unique, what it's doing is it's enforcing the fact that even if I try to insert this thing again, it's going to fail. That this unique is going to ensure that there's only ever one of these URLs listed in this table. Or if we come down here to the users table, this primary key right here, so this unique key right here, is going to ensure that there's only one user entry for any particular user in this table. Let's go take a look at the services / pg _ denormalized schema.sql. And taking a look here, we see there is no primary keys, no uniques involved right here. And so when I insert something into this table, there's no checks making sure that the data that's being inserted is valid somehow. And in particular, if I were to, so down here, if I run the loadtweets.sh script again, okay, so we can see that the everything's running again. It's doing its thing. These inserts up here at the top, these inserts up here that are running the Python, running into the normalized, they're hitting those unique constraints, and the unique constraint is making the database not allowing it to add multiple things, and again, that have already been added. But down here, when we do the load denormalized, one of the reasons that the denormalized version is faster than the normalized is because it makes no checks on whether our data is valid or not. And so now when I've loaded the denormalized again, I've just added more things in here, and I have duplicates now because I've loaded this data twice inside of here. And I can check that by, let's go ahead and, so docker compose exec pg denormalized bash like this, then psql, and let's do a select count star from, I want, there's my cursor, from this table right here, tweets _ JSONB like this. And we can see there's a lot of rows in this table right here, about 40,000 of them. I'm gonna press Control D, exit out of that, run this loadtweets.sh again. And so it's doing its thing, loading a bunch of stuff. This one up here, doing all the checks again, when it's doing the normalized up here, checking to make sure we're not making any mistakes in our data. When it do the denormalized one down here, it's not making any of those checks. So now we can see, now we have 50,000. We've just added another 10,000 tweets into this database. And so because we keep on adding all this duplicate data, that's why our checks are failing. That's why when I run /check answers here, we're getting a whole bunch of, so some of them happen to be passing, but a lot of them are going to be failing because there is that duplicate data and it's not expecting that duplicate data in the checks. Are there any questions before we talk about how to fix this problem? Are there any questions just about what the problem actually is? Yeah, sorry.
So like with the normalized version also not checked, like within the insertion itself, like 10,000. Would it also not check duplicates in that one insertion?
Oh yeah, great question. So if in the zip file we had like one tweet repeated 10,000 times, it would not be making any checks about that. It would just raw copy it over. So yeah, it makes no checks anywhere about the consistency of the data. And so that's one of the reasons why it's faster, but also like a major limitation of it when you're actually working at scale. Good question. Any other questions about just what this problem is before we talk about how to fix it? Okay. So then, yeah, how do we fix it? The key for this assignment, really what's going to be the hard thing about this assignment is managing the volumes that you're working with. So if you recall, when we do Docker compose, say down, that's going to delete the particular containers that we had, and but it's not going to delete the volumes. The volumes store persistent information that is going to stay with these services between bringing the containers up and down. So I just brought it down, just brought it back up. Let's real quick do our exec again, psql select count star from tweets underscore JSON B like this. And we can see we still have this data right here, even though we destroyed the container and brought it back up because the data is being stored in a volume. If we do Docker volume ls, it'll list all of the volumes, and you can see we have two volumes here, one for the denormalized database and one for the normalized database. If we open up our docker compose.yaml file again, you can see under the volumes right here, each one of the services has two volumes listed. This first volume is, so to the left of the colon, we have a relative path. So this is mapping the current folder onto a folder in the container. This folder in the container, let's go ahead and just take a look at it. This folder in the container /temp/db just contains the contents of our of this folder right here, of the folder that we're working with, of our project folder. And so this mapping right here was to allow us to efficiently edit something on the Lambda server, and it'll take effect inside of the container. And we know that this is, this is a relative path over here because it starts with a dot. This one down here is not a path. This is a named volume, PG normalized. And because it's a named volume, when I do Docker volume ls down here, it lists the volumes down here. The actual fully qualified name of the volume is the name of your current folder when you're using Docker Compose, so Twitter_Postgres, Twitter_Postgres, and then the name of the volume that you have listed up here in the Docker Compose file. So up here we have PG normalized for the PG normalized, and then PG denormalized for PG denormalized. And so those are our two volumes. And in order to actually delete the data and reset things, we have to do Docker volume. The easiest way to do it is Docker volume prune. Prune will delete all of the information, all of the volumes that are not currently being used. Here you can see that it says my total reclaimed disk space is 0 bytes. That should be suspicious to you because I know I've stored data in these volumes. And so if I have 0 bytes reclaimed, it means that I probably didn't delete anything. And if I do Docker volume ls again, we can see that these containers are still listed right here. The reason that they're still listed is because Docker ps, I still have those containers running. The Docker volume prune command won't delete volumes that are actually currently being used. So I'll have to do Docker compose down to bring down the container. And now if I do the Docker volume prune, now we can see that it's actually deleted those volumes right here. Docker volume ls, those volumes are gone. The volumes will automatically be recreated when I bring the rerun the up command, Docker compose up -d. And now I can run the sh load tweets.sh. And now you can see actually this, this script right here, inserting the data, is taking significantly longer. It was already really slow, but now it's even slower. It's like 5 seconds per 1,000 tweets, because now it's actually not just trying to insert it, seeing that the unique blocks it, and so it can't insert. It's actually doing all of the steps of an insertion. And so this is going to take, I don't know, 30 seconds or so for all of these to be inserted. And then when we get to the loading the denormalized, that'll still be fast, still under a second. But because there's no data in there, it'll actually be correct. It'll have inserted the data only a single time. Almost done. Yeah, we can see that it took 23 seconds here to load 10,000 tweets in the normalized version, still 0.3 seconds in the denormalized version. And now if we do the exec again, pg underscore denormalized bash /check answers. Now everything will pass because there's no duplicates in the data. So the takeaway from all this is that if you are somehow not sure about like the status of the data in your database, you can always reset things by running the 2 commands of Docker compose down, bringing down all of your containers, and then Docker volume prune, saying yes, and that will reset all of your databases to sort of like a factory fresh state, and then you don't have to worry about duplicate data screwing you up at all. Here in my solution, this is only a problem on the denormalized one because the denormalized is, or because the normalized is implemented correctly. Depending on if you have mistakes in the normalized one, you may have to do this for the normalized one as well. So it's just sort of a good habit to be into, knowing how to like reset everything to this fresh state and checking on this fresh state. Any questions on, yes?
So I'm a little confused, like how to conceptually think about what a volume is. Is it like a container, like a separate database, like a mix of the two?
Yeah, so good question is like how to conceptually think about what exactly is a volume. The way I think of a container is like a virtual laptop, and a volume is like a portable hard drive. So if I have a USB hard drive plugged into my laptop and somebody comes along with an axe and smashes my laptop, the volume is still okay. The external hard drive is still okay. And I can take that external hard drive and I could conceivably plug it into a different laptop. I could plug it into a different container. I could even, you probably haven't done this before, but you could have one external hard drive connected to multiple laptops at the same time. And that's totally okay. So yeah, the volume, external hard drive, container, laptop. That.
Yeah, one more question. So like at the bottom of the Docker compose file, you have like, I'm looking at the GitHub right now, it's the name, PG normalized. Are those just the names?
Yeah, so then down here, question is there's this volumes field down here that we didn't talk about, and what's going on here. In this volumes field, we have these, PG normalized and PG denormalized. And it's possible with volumes to list all sorts of special different options with them. So some of the things that we could do is we could say, like, I really want the, so we've mentioned in this class, we have two sort of types of hard drives on the Lambda server. And I really want maybe the denormalized one stored on one of those hard drives and the normalized one stored on another one. And so one of the things I could do down here is specify like the actual physical location on the disk that those things are stored. One of the advantages of Docker is that we can relatively easily so now we have like sort of two databases right now. They're both being launched. They happen to be launched on the same Lambda server. They could be, if we were like on AWS or Microsoft Azure, we could be launching them on two separate systems. And if we were doing that, then these two things down here, they can specify like what types of hard drives do we want AWS to allocate for us for these volumes to adjust like how much we're paying for them. So yeah, this is just like basically the configuration of your external hard drive, how much space it has, all those things.
And are these specifically for each of our containers? Is that why they're the same names as the services?
The question is, yeah, these containers happen to have the same names as our services, and what's the deal with that? The answer is that I named them the same just so that it's obvious that like PG denormalized or PG normalized here, the volume corresponds with this container right here, but there's no requirement that it be named that way. And so I could call this one just like blah, and then down here, change that to blah, and that would be totally cool. And I could even make both of these use the same name, putting them on the same container. That would happen to make Postgres really confused and break things because it's two different Postgres instances thinking the databases are different. So that not a good thing to do, but we could do that from a Docker perspective. In general, 99% of the time, you want like one volume per container. And so it's good to just keep them the same name for consistency. All fantastic questions so far. Any other questions? Is this all people mostly tracking with the volumes? Seems to be making sense. Okay, I see a lot of head nods. That's good. Okay, then so in order to implement so let's talk about the actual implementations now. In order to implement the loading the denormalized, it's just this one line right here. Loading into denormalized databases is super easy. This is like it's a complicated incantation, but once you get that incantation sort of set up correctly, then it just works and it's really fast. And again, on the notes for this week, there's a link that goes into the details of what all these parts of this incantation are doing, if you want to take a look at that. But it's going to be a little bit different depending on whether you're loading JSON data or CSV data or whatever the source of the data is. The main programming part of this assignment is this loadtweets.py. And so I want to take a look at this file. And let's go back to the master branch while we do that. So up here, I'm going to do colon. So in order to leave everything at once, instead of just doing :q, that'll leave just one tab at a time. I want to leave all of my tabs at once, :qa. The A stands for all, leaving all the tabs at once. And what I want to do is I want to open up the loadtweets.py script. So loadtweets.py. And let's just go Shift-G just so we can see it's 292 lines long. I think last time we talked about So when you're see a new Python script, how do you figure out like just what it does? This is a lot of lines of code. Where do you start looking? And the first thing to do is always to look for this line right here, if name equals main, because this is like the main entry point. This is where the program is going to start at. And then we have a bunch of command line arguments right here. Talked about creating the database connection. Every script needs both this engine and this connection object. These two things are created by the SQL Alchemy library. SQL Alchemy, again, has an ORM, operational relational mapper that it's popular for. Some major websites like Reddit use that ORM, but Reddit is also known for being slow and having lots of downtime. And a lot of that is caused by the ORM because it's difficult to get efficient operations with the ORM. And so we're going to be using SQL Alchemy just for putting raw SQL statements together so that we can be in fine-grained control of our efficiency. And SQL Alchemy gives us a sort of generic interface that works with any database system in order to provide it with raw SQL statements. And again, it knows which database system we're working with. Let's open up loadtweets.sh again. Let's go ahead and check out solution up here, :E to reload it. It knows which database it's working with because in the URL, the schema of the URL tells it which type of database to try to connect to. So PostgreSQL, try to connect to Postgres. Okay, back to master. And then we have this big looping that's looping through all of our data. There's some subtle things about why this is happening, why it's doing things the way it is here, which we'll talk about later. But for now, all we need to know is that this tweet data is giving us one line at a time, one of these JSON objects, and then we're calling this insert tweet function to actually insert it. And some cool Vim tricks. Again, if ever you're on like a function, you want to go to its definition. GD takes you to the first occurrence of, so G for go, D for definition takes you to the first occurrence of a particular word in the file. And so for functions, that will take you to the definition of the function, but you can use it for variables or anything else. And then this is the function that you'll actually have to be implementing. In this this file, or this function, it's divided up into a bunch of sections that look like this. And in each one of these sections, there is a SQL statement like this, which you'll have to provide the actual SQL for in order for it to do the inserting. We'll take a look at, I don't know, there's, I think, 10-ish tables. So there's 10-ish of these SQL commands that you'll have to insert. I'm going to pull up the solution here for this one in a little bit so that you can see exactly what the sort of format's going to look like. But before we do that, I want to just get a little bit more familiar with what this code is doing and see a little bit more tricks for how to get familiar with code. So at this point, yeah, we've seen there's this one function right here that we're looking at, this insert tweet function. But like just looking at the line number, this is line 76. So there's a lot of lines beforehand that we haven't looked at yet. And maybe there's stuff after this, but maybe not, I don't know yet. And if we come back down here, looking at here, there's this get id URLs, and I can tell it's a function because of the formatting right here, but like, I don't know, is this like defined in this file somewhere? Is it a library function or what is it? And so one of the tricks that I commonly use when I'm encountering a new Python file trying to orient myself is the grep command in the shell. So again, we've talked about grep before. Grep allows you to search for regular expressions in files. And in Python has the def keyword for defining a function. So if I want to list all of the functions in a particular file, I can do grep def and then the name of the file that I want to search. So here, loadtweets.py, like this, hit enter. And so we can see that there's these 3 function definitions right here. And then there's this little bit of noise over here. So def happens to be in this default word right here. With this, it's only one line of noise, so I could figure this out myself, I don't need to do a fancy regular expression right here, but the up caret stands for like the beginning of a line in a regular expression. So this is really the regular expression that I use when I'm trying to find all the functions defined in a file like that. And there it gives me what they are. Sometimes I like to know what the line numbers are, and so -n gives me the line numbers as well. Yeah, so these are the 3 different functions inside of this file: insert tweet, get id URLs, remove nulls. And so the insert tweet does the actual inserting. This get id URLs is actually probably the most complicated function. And so I want to take a look at this function and how it fits into everything here for a little bit. So in order to find where that function is defined, well, I knew since I had my grep down here, I could just do 41GG to get there. 41GG, and that would take me to it. If I'm going to go back to where I was before by hitting the single quotation mark twice, that jumps you to wherever your cursor previously was. And now I'll move my cursor under the get id URLs and do GD like this to find the actual definition of it. And a good way to figure out, like, okay, why is a function, or how is it used, or like what's the purpose of a function? I mean, you can read the source code of the function, but sometimes it's good to just like see where it's actually used. And so when you do the GD, it does a search for this function, and you can just press in to find all the occurrences of that function. And so we can see where the locations that the function are actually used. And so we can see that the first parameter to this function is always somehow like a URL that's somehow extracted from the tweet, and can be from a lot of different sources, but it's somehow a URL. And what this function actually does is it converts the URL into a number. And so this is going to be needed for our normalization process. I'm going to open up our schema again. So tabby services /pg_normalize/schema.sql over here. And here in this URLs table, this is going to contain all of the URLs that we have. And here we have the ID of the URLs, which is just going to be a number. Big serial, I don't think we've talked about serial yet, but big serial is the same as a big int. Big serial equals big int plus an auto incrementing feature. So very first time you insert, it'll be 1, then 2, then 3, and it'll be monotonically increasing. Big serial stores numbers up to 2 to the 63. So really, really big numbers. And so we can store a lot of different URLs this way. And then whenever we wanted to get like the actual URL from a tweet, we'd be doing various joins on the id URLs. Id URLs. We can see that there's a lot of different things inside these other tables that have foreign key references into the id URLs. And again, these foreign key references are something that that the normalized database is going to be ensuring for us. It's going to ensure that every time there is a user, that if that user has an URL associated with it, that URL is guaranteed to exist in the URLs table. So in order for us to insert something into the users table, because there's this references clause into the URLs table, we must first insert something into the URLs table. Okay, so how does the get id URLs function work? It has an insert into URLs. This function is totally implemented for you already. You don't have to modify anything about it. And in fact, it's a good reference for how to do the mechanics of inserting into the SQL database. So we're inserting into the URLs. Here we have our standard sort of insert statements. Last time we talked about SQL injection and that you want to avoid SQL injection. So whenever you're putting together a SQL statement, you never use Python string manipulation functions. Instead, if there is a value that you want substituted, you do the colon and then the name of a variable. And then in your connection.execute function, you provide a dictionary, which will map all the colon values to some actual Python value, doing the substitution, escaping everything properly so you can't have SQL injection. If you use this colon syntax with a dictionary down here, guaranteed NoSQL injection. If you don't use that and try to manually escape things, you will probably have a SQL injection vulnerability. So here, this is inserting into the URLs whatever that particular URL was that was passed in here. This on conflict clause, what that means is that, so sometimes, so remember primary key is unique and not null. So sometimes, and down here, the text is unique. So when we insert into URL, sometimes we will have a conflict on this unique key right here. That conflict means that that URL already exists. And so if the URL already exists that we're inserting, we don't want to insert another URL that's exactly the same. Instead, we want to get back the ID of the URL that already exists. So on conflict do nothing means that don't insert if it conflicts with the unique constraint. And then this returning id URLs right here, it's like combining the insert statement with a select statement so that you get the ID of the URL as you're inserting it. And again, the ID is defined by this big serial right here, and so it's automatically defined for us. So this insert combined with the returning is the same as an insert with a separate select statement afterwards. It's just both more convenient typing-wise and more efficient implementation-wise to combine it into a single statement like this. In order to actually get the results, in order to get the value of this id URLs right here, this result right here, so connection.execute, SQL is the SQL query right here. This dictionary right here, again, is the mapping of all of these colon variables right here, giving us the Python value that should be substituted at this particular location. And this right here will give us a Python iterator. So you can think of it like a list, not technically a list. It's just a generic iterator object. And in order to get the first thing, the first results, you can do .first. You can do any of your other Python iterator manipulation things to this. So in this case, because we know that the URL must be unique, and after the insertion, there must be at most one, there must be exactly one URL that's been inserted. .first, this is guaranteed to always have exactly one entry in it, and so we can do .first to get access to it. This result right here will be a dictionary object, a dictionary containing all of the things that are being selected from. In this case, we're returning id URLs. So results will contain id URLs. Scroll down here for a bit. The very 0th position, the only position, will be the id URLs, and so it's going to return that value right there. One last thing about this, somewhat annoying for the returning clause. If there is a conflict, then returning does nothing, it returns none. And so if there is a conflict, we do need to have a separate select statement. So what this comment right here is just explaining out in words that if res is none, that means that the on conflict happened, so returning did not happen. And we do need a separate select statement selecting id URLs from URLs where URL equals whatever got passed in, and we'll get the URL that way. So you don't need to know the mechanics about what this get id URLs function is doing under the hood, except that it's a really good reference on how to use the on conflict statement and how to use the returning statement in order to actually get the values that you need when you're doing your own inserts. Covered a lot of things right there. Any questions about any of that?
I had a question about the graph.
Yeah.
So with the graph command, do you also get like for example, next few lines after the verbs of that?
Oh yeah, so the question is like with grep here, right now we're only getting the function definition. Maybe we wanted to get the next few lines as well. I'm sure you could. I don't know off the top of my head how to do that. That's not something that I've ever felt the need to do.
What is the upper rule line for grep?
Yeah, the question is what exactly is this up caret doing right here in grep? The up caret matches the beginning of a line. So the difference between this and this without the up caret is that the DEF right here matches default right here. So it's not a function definition. But if I actually just want function definitions, those in Python must happen at the beginning of a line. And so that's why why we have this. Those of you who have programmed in C or Java or any of these other languages might not like or might have found this like style of Python function definitions weird. But the reason why Python and all modern languages have a specific function definition keyword is so that it's easy to grep for function definitions. You can't do that in older languages. Let's see, so we've talked about the get id URLs function. There's this weird remove nulls function that we haven't talked about yet. So what's going on here? Let's go ahead and take a look at line 16, GG, find remove nulls. And we'll see that it has, this is the only function here that has some doc tests inside of it. We can run those doc tests just fine. Python 3-m doc test load tweets.py like this. And it runs those doc tests and we see that it passes. So there's no actual changes that you need to make to this function up here. This function up here is just something that you'll have to use when you're writing your insert tweets function. In general, when working with databases, one of the arts of programming with databases is breaking up your functions into functions that don't need database access, functions that can be tested with doc test because they don't need database access, and then functions that do need database access, like the get id URLs and insert tweets. Those do need database access, and so in order to test those functions, we need this whole big setup of Docker Compose and all these fancy test cases. So one of the arts of good database programming is breaking up these functions into smaller chunks like this that can be tested just in Python. But what this remove nulls function does, if you recall, in so the null character, the \0, byte 0, this is not allowed in any strings in Postgres, and in particular is not allowed in JSON objects or text objects or anywhere inside of Postgres. And that's due to historical reasons about implementation details in C. And again, the developers are wanting to remove this restriction, but at this point they haven't done it. And so the Twitter, though, allows tweets with the null byte inside of it. And in the full data set of however many like billions of tweets that was, I think there are 3 tweets that contain this null byte. So it is the least popular character in Twitter, but it still occurs occasionally, especially on like programmer or security related Twitter accounts where they're trying to break things. And so this function will remove those null bytes from the input. So replacing that with just an empty text. The zip file data does contain some strings that have null bytes inside of it. And so when you're doing your inserts, anytime you have a string, you'll have to pass it to the remove null function before actually passing it to Postgres, or you'll get an error message saying that you can't insert null bytes. Last thing we're going to do today is actually see an example of combining all these things together and doing that first insert statement. Before we do that, any questions about this function here? Okay, so let's go do a git checkout solution. And then up here, I'm going to do :E to load the solution. And I want to insert tweets. And let's scroll down until we get to the, so insert into the users table. This is the, again, we talked about that every one of these little sections is going to have a SQL statement like this that you're going to have to create the code for. And so for this one, I'm going to show you exactly what that code is going to look like. So here is the insert statement. And again, this will all be on YouTube, so you'll feel free to, when you're first working on this, just copy this verbatim from the video if you'd like. But here we're inserting into the users table. I know it's the users table because it comes right after the insert statement. And I know I'm supposed to be doing it into the users table because that's what this section tells me up here. In the users table, there's a lot of different columns. I know all of the columns because in the schema.sql, let's search for the users table. There it is. It's easy to center. There's all of these columns down here. All of these columns are things that I have to fill out correctly in order for the test cases to pass. If you don't fill out one of these columns correctly, then the test cases will not all pass. And so all of these, I have all the columns listed right here. In their, the very first line is what they look like in the SQL. And then the second line down here is the list of all the values that I'm going to be inserting. All of these values, again, have the colon in front of them, so they're doing the substitution. And if I scroll down a little bit more, under the execute statement, you can see that there's this big dictionary that contains all the colon statements to the left and the particular value to the right that needs to be inserted at that location. In order to know what needs to be inserted into a particular value, there's two things to check for. The first one is up at the top. If there's ever any sort of computation that is needed to happen, I will be doing that computation for you. I've already given you all the computation that needs to happen. So like up here, there's this user id URLs. It's already computing what the, so it's getting the URL right here, and then it's computing what the ID of that URL is right here. And this is what you'll insert into the, into the id URLs column like this. Id URLs, user id URLs. And hopefully from the names, it should be relatively straightforward about what column goes where. The columns are not exactly matching what the Python variables are up here because there are multiple tables that are being inserted. So there are multiple columns named id URLs throughout the different tables. And this is the id URL specific to the user table that's being inserted. So that's why it's prefixed with the user right here. All of these other values, they come straight from the JSON object. So because we're going into the user table, it's the all the information from the tweet at user location. Maybe the only thing sort of tricky is the updated at is whenever that particular tweet was sent, that's when we got the latest information about the user, but everything else comes from the user table. Anything that is a string or text object of some sort needs to have the remove nulls applied to it. So the screen name, it is possible in Twitter to have your screen name contain a null character, which will break a lot of people's code, but it will not break your code because you will apply this remove nulls character before trying to store that in a database. And then there's a lot of different lines, inserting everything. And the execute function is what's actually going to insert it into the table. Here, so I have this on conflict on id users do nothing statement right here. A slightly more correct could be on conflict update and set all of the values to something that's more updated. But it turns out that that's a slower thing to do, and the way that the rest of the code is written, it's actually never needed to update any of those other values. So for your code, all of your things, you can do an on conflict do nothing to handle the conflicts. If you don't have this on conflict do nothing, then Python will throw an exception when you have a Postgres exception, and you'll have to handle it with a try except block in Python. Any questions about that example? Okay, my hope is that these inserts for all these tables will be pretty mechanical of just getting this inserted, and you should feel the pain of using this normalized schema. It should be painful doing all of this. That's why people like MongoDB and these other sort of NoSQL solutions, the denormalized solutions. Much easier to work with sort of initially, but and we'll see that again, faster without doing fancy stuff, but that has that problem of no enforced correctness on your database. Yeah, so that's it for today. We'll talk about, again, Wednesday,